In this example, I'd like to show you how you can use normal distributions to find percentiles. So that's finding a value of x when you're given a percentage. In this example, we'll be talking about the medical college admission test scores, so MCAT scores. And we know that these follow a normal distribution with a mean of 25, so a population mean of 25 and a population standard deviation of 6.4. And so one good way to always start with a normal distributions problem is to start by drawing the distribution. So this is our normal distribution with a mean of 25 and then 1, 2, 3 standard deviations up from the mean. We can fill in these values, so 1 up would be 31.4, 1 standard deviation down is 18.6, and I'll go ahead and fill in the other values, so 37.8, 44.2, 2 down is 12.2, and 3 down is 5.8. So once we've drawn in our distribution, let's go ahead and see what we're supposed to find. So what score did only 10% of students score better than? So what we're going to try to find here is basically a value when we're given a percentage. So let's go ahead and shade in the region that we're talking about. This we know from the 68, 99, 95, 99.7 rule is that anything above this 37.8 will be about 2.5%, and anything above 31.4 will be about 16%. So we're somewhere in between the 31.4 and 37.8. This is just an eyeball, and this is then the 10%. Top 10%. So only 10% of students scored better than some mystery score right here. This is what we need to find. Well, we can do this by finding then the z-score that is associated with this value. So what I mean by that is we want to find the probability that x is less than some score is equal to 0.90. Now, why did I do that? Well, because the top 10% also then, the value that cuts off the top 10% also then cuts off the bottom 90%. Well, we typically want to deal with the lower half or the percentile when we're using then the standard normal table. So the probability that x is less than some mystery number, let's just call this, something, is equal then to 0.90. Well, we can then say, all right, well, let's calculate this as a z-score. Well, we want to do a probability that z is less than some mystery number minus our mean of 25, all divided by our standard deviation, is then still equal to 0.90. Well, what we have to do is we have to find this z-score that makes this true. So let's go over to our standard normal table, and we want to find the z-score that is associated with 0.90. So I can see right here that I have two values. It goes from 0.89973 to 0.90147. So I don't get exactly 0.90, but it falls somewhere in between there. So I'm going to say the z-score that is associated with 90% of the area falling below that is 1.2. And then if we scroll up about in between 0.08 and 0.09, so 1.285. So what this means is that the probability of z being less than 1.285 is equal to 0.90. And so then this quantity, question mark, is equal to then, or question mark minus 25 divided by 6.4 has to be equal to 1.285, which with a little bit of algebra we can easily calculate this. So moving over our standard deviation and adding over our mean, we get then the mystery number to be equal to 1.285 times 6.4 plus our mean of 25, which then is equal to 33.22. So this value, 33.22, seems to make actually some pretty good sense. Once I've drawn the distribution, 33.22 is then the score in which only 10% of the students scored better than. In this next example, we want to find the score in which only 10% of students did worse than. So again, we can kind of go with the same method as we did before. We know that everything below 12.2 is about 2.5%. Everything below 1 standard deviation down from the mean is about 16%. So our 10% will be about this proportion on our standard normal distribution. And so this is about the 10th percentile. And we want to find this mystery value. So what is then this score in which only 10% of students did worse than? Well, we can calculate this just like we did in the previous example. The first thing is that we want to find the probability that X is less than some mystery score, and this is then equal to 0.10. Notice that I don't have to do any sort of kind of subtract from 1 or anything like that, because I'm already looking at the area that falls below the score I'm interested in. So I'm looking at the percentile. So this is then, if I want to convert it to a z-score, z is less than my mystery score minus 25 all divided by 6.4 is equal to 0.10. So I need to go find the corresponding z-score that makes this be true, that in which 10% of the data fall below that value. So I'm going to go over to my standard normal table. And something to think about is that anytime you have a percentage below 50%, your z-score will be negative. So I want to find 0.10. And so I'm getting a little bit closer when I'm looking at this row and I find these two values. It says 0.10027 and 0.09853. This is about the closest I'm going to get. So this starts with the z-score of negative 1.2. Starts with the z-score of negative 1.2 and then goes up to 0.08 and 0.09. So I'm going to go right in between there and say that this z-score is negative 1.285. So the probability that z is less than negative 1.285 is approximately 0.10, which means that my mystery minus 25 divided by 6.4 is equal to a negative 1.285. And again, with a little bit of algebra, I can solve for my score that I want. That's going to be negative 1.285 times 6.4 plus a 25. And this will then give me a value of 16.776. Now if I come over here and I put in my value of 16.776, it seems to fit right where I thought it should. So the value makes perfectly good sense with the drawing that I've done. Always make sure that these things match up, as it's easy to switch which percentiles you're using. That's why the visual display will help you get a better understanding of what value you're looking for. So what this means is that 16.776 is the score in which only 10% of students did worse than.